That's the simplest way to remember what this is. Okay, think of it as the annual return that the project has generated. These cash flows, you just converting them into a percentage to represent a return. Okay, so what happens is this internal rate of return technique is a continuation of the net present value technique. So this is the point I need you to remember. Okay, please write this down, colleagues, so that in the exam you don't forget this. When your first net present value is negative, when your first NPV is negative, reduce your discount rate. Reduce the discount rate. Okay? Because remember, with the internal rate of return, you want two net present values. One has to be positive, one has to be negative. Okay? So if your first net present value is negative, reduce the discount rate. Okay? One rule of thumb is you can divide the discount rate by 2. Okay? Or you just pick by yourself. You just say, okay, I'll choose this discount rate. Okay? It's up to you to pick which one you need to use. Okay? Then, when your first NPV is positive, increase the discount rate. So one way to remember this is if you see a negative sign, it means continue reducing. Okay? If you see a positive sign, increase. That's one way you can remember these, colleagues. Okay? Yes. So our first net present value here, negative 13.38. It's a negative. So we can choose our next discount rate. Okay, so in the exam, because there is no time for trial and error in the exam, okay, you don't want to be just trying different discount factors and you find you're still getting a negative one. So I always advise be extravagant in the exam. Okay, so like in this case here, we'll just go straight to a discount rate of 1%. Okay, be extravagant. Okay, you can also use 2%, you can use 3%. Okay, anything below 21.5% you can choose. Okay, but always in the exam just be extravagant, because at times you might choose a discount rate, you find you still get a negative one. So it means you have to continue with trial and error. Okay. So here our new discount factor is 1%. Okay. 1.01. Okay. Remember, R 0.01 plus 1, 1.01. Okay. For year 0, always the discount factor will be 1. Okay. For year 1, here's the discount factor, 0.99. Year 2, discount factor 0.98. Year 3, discount factor 0.971. Year 4, 0.961. Year 5, 0.951. Year 6, 0.942. Okay. then you repeat the process again. Cash flow multiplied by discount factor. Okay, the cash flow still stays the same. Cash flow multiplied by discount factor. Cash flow multiplied by the new discount factor. Okay, cash flow multiplied by the new discount factor. Okay, again cash flow multiplied by the new discount factor. Cash flow multiplied by the new discount factor. Cash flow multiplied by the new discount factor. Okay, colleagues. So we add up. Okay. All these numbers, you add them up. Okay. Negative 195 plus 78 plus 58 plus 57 plus this plus that. We get 93.43. Okay. Yes. Any questions before we now go to the second step?
So this one is supposed to be done on the ARR on when we are calculating the IRR.
Yes, it's the IRR, madam.
Yeah, Mr. It depends whether you are going to nursery or not. So, so this one you're supposed to do it when you are now tackling the IRR.
Yes. IRR, colleagues, sound international. Eh? The IRR, okay? Sound international.
So I think I missed the point. I just explained instead, but
Okay.
how did you get the figures on discount factors, especially maybe 0.99 and also 0.
We are using this table, sir. The table. This table, sir. You just read here the percentage, then the years, you just come here.
Okay.
So, sir. Sorry, I have a question. You said year 6 is a cash out year.
Yes.
Again, why are we getting the figures from the table for year 6 to be on the to calculate the 0.94?
You want to find out?
Why are we not using the year 5 to calculate for year 6 because it's a cash out year?
Because, madam, as we said, since it's paid in year 6, so you have to use the discount rate for year 6. Okay, it's paid in year 6. It's for year 5, but it's being paid in year 6. So that's why we used the discount factor for year 6. Is that okay, Madam Anita?
No, it's not.
Yeah.
I'm not understanding because Madam Sylvia, she asked the area to say, why are we not, how can I put it? Why are we not using like the one which we used at first to say it's a scrap year? Something like that. We're getting it.
Madam, scrap value. Scrap value.
It's different with this
yes,
one.
It's different, yes. Here they've told you the tax is payable in arrears, meaning you have to pay it the next year. Okay?
Okay.
Yes, so that's why you have to keep it as, put it there by itself in year 6. If you put it in year 5, you'll get it wrong, okay? Because you're not paying that one in year 5, you're paying it next year.
No, okay.
Yes, but when it's scrap value, yes, you can put you put them, you add it on the last year there. So it's good you brought up that point because maybe someone would have done scrap value the next year. So it's good you brought up that point.
So let's repeat it again.
Scrap value, you put it at the end of the project. You combine it with the last cash flow. Now a tax which is payable in arrears, you take it to the next year. Is that
Okay.
Yes. Okay. Then the last part, now you put it in the formula. So this formula will be given to your colleagues. Do not worry, okay? You don't need to memorize it. Okay. Just remember, you're only getting 4 things from this formula. So let me just write the formula here. L%, L is the lower discount rate. L%, lower discount rate, plus the net present value, NPV, with the lower discount rate, NPVL. Okay, NPVL is the net present value with the lower discount rate, over NPVL minus NPVH. NPVH is the net present value with the higher discount rate. Okay. Then H% minus L%. Okay. Other books you see it as A and B%, but I like to use H and L so that you know which one is which. Okay. So colleagues, L% is the lower discount rate, which we said is 1%. H% is the higher discount rate, which we said 21.5%. Okay. NPVL, the net present value with the lower discount rate, is this 93.43. And the net present value with the higher rate is negative 13.38. Okay. Just remember, in that formula, you're just dealing with 4 figures. Okay. The 2 discount rates and the 2 net present values. Excuse me. Okay. So we just do replacing here. L%, we put 1%. Okay. If you want, you can convert them, these percentages, into decimals, but then at the end you have to convert it back to a percentage. So what I advise is just leave them as percentages. Okay, colleagues?
So, sorry, on the NPVL, it's net present value with lower percentage rate.
Yes, the lower discount rate. So if you remember, when we used 1 as our discount rate, our net present value was 93.43. Then when we used 21.5 as our discount rate, we got negative 13.8. Minus net present value with a higher discount rate, negative 13.38. Open brackets, 21.5 minus 1%. Okay. Just leave them as percentages so that your final answer, you just get it as a percent. So, order of operations. Okay, you start here at the bottom. 93.43 minus negative 13.38. Colleague, someone to do the tabulation for me. 93.43, as I'm just writing this step by step. 93.43 minus negative 13.38.
So on NPVL minus NPVX, why are we starting implementation from 43 from NPVL?
Because NPVL size the net present value with a lower discount rate.
Yes. Oh, okay, because of 1%.
Yes. Huh? That's
Because of
noisy.
1%.
It's the one, yes, the net present value when we use the 1% is 93.43.
Okay, sir.
Yes. 93.43 minus negative 13.38, what do we get?
107.23.
107. That's Mr. Emmanuel.
Yes, sir.
Good evening, sir. How are you?
I'm okay, sir. How are you too?
So
I don't know, maybe it's my calculator. I'm getting 106.81.
Sure, let's see. Let's confirm. 93.43 plus 13.38. Well, 106.81. Mr. Emmanuel, what are you calculating, sir? How did you get 107?
He's using a small point to calculate.
106.81. So 93.43 divided by 106.81, we get 0.874. Okay, 0.87. 0.87 multiplied by 20.5 . 17.93.
Sir, for the sake of Mr. Tuambo there, this one, the one in brackets, the 20.5, I said, for the sake of Mr. Tuambo, maybe you should add a percentage there. He might get confused when he's watching the video.
Oh, yes. For those who are just listening in and just remembering answers. Hey.
Sir, is this person doing that because of me or maybe for his sake?
No, it's for the benefit of everyone, so that when you're watching, because there was no percent here, then I brought a percent sign here, so that can bring confusion. Okay? Yes. So this is the return the project is generating, 18.93%.
Sir, before you say about rejection, I think it would be nice to just answer the question now. Whether it's possible to reject. Is it the part where we're supposed to advise whether we reject it or not? Looking at what you said.
This is where I'm coming to, sir.
Oh.
Yes. So if the IRR is less than your cost of capital or your expected return, reject. DODA wants 21.5% as a minimum return. This return this project is generating is 18.3. Okay. So if the IRR is less than the expected return, reject. It means the return you're getting from your project is less than what you expected. Okay. Or if it's against cost of capital, the return is less than the cost of financing of the project. Okay. So in this case, just now once you reject from the NPV, automatically with the internal rate of return, you're rejecting also. Yes.
No, I didn't get you, sir, concerning the question Mr. Pastor.
Just come again, Mr. Twambo.
No, I wanted to. No, Mr. Kasongo asked you a question, so I didn't get the answer.
If the internal rate of return is less than your cost of capital or your expected return, reject the project. Okay. In this case, DODA wanted a minimum return of 21.5, but this project is generating a return of 18.93. Okay, so you reject. The internal rate of return is greater than your expected return or your cost of capital, then you accept. Is that okay?